So with question 4, the question reads, the following diagram shows a basic signal compression circuit. It is part of a system that is used as a temperature measuring device. Now, what this basically is that this is an application question, okay? You are expected to really understand operational amplifiers before you can solve this question. However, I'm going to make it simple for you, okay? So we have our op amp with its output V naught, and we have the inverting and then the non-inverting terminals, okay? So this is grounded. Now this section has a resistor, okay? And then there is a feedback loop from here to that place. So we have a feedback loop, and the feedback loop has
The B out.
a diode. Pardon my sketching, eh?
Okay.
Set.
And then we have our supply, which is also grounded. Now this, and they say this from the question, this is a sensor. We have V in here, we have R in here. And then this is ambient temperature.
Temperature.
And they say this is an ideal op amp. And this is D1, okay? Now, I is saying that we should find an expression for the output voltage, which is this, as a function of the input voltage, which is V in. Sorry. So V in. Okay, so we are being asked to find the output voltage as a function of what? The input voltage or the temperature to be measured. Okay. Now, in the question, we are told that temperature is approximately V in. Okay. Now, this circuit you see here is a logarithmic amplifier. Okay. So when you get time, read about logarithmic amplifiers. For now, I don't want you to spend so much time trying to read about it, but when you get the time, you can go ahead and read more about it. Okay?
Okay.
But for the purposes of this solution, I just want you to note that this is a logarithmic amplifier. Okay?
Okay, sir.
Okay. So for a logarithmic amplifier, V out is equals to minus VD1. Okay? The output voltage is equal to the input voltage times the voltage across, sorry, the output voltage is equals to the voltage drop across the diode. Do you understand?
Yes, sir.
Yes, sir.
Okay. Now, note all what I'm writing and write it out nicely for yourself. So for a logarithmic amplifier, its output voltage given by V out equals to minus VD1. Okay, sorry, because of the inverting. Sometimes if you don't take care, you forget to add the negative. Okay, so take note
So
of
please
that. Mhm.
D1.
VD1, yes.
Diode 1.
For the diode, D1, diode 1.
Okay.
And then the current, which is I. So what happens is that I, for the input resistor, IR in, is equals to current across diode 1, which is the same as voltage input or input voltage divided by input resistance. Okay?
B E
So let's say this is equation 1 and this is equation 2. But VD1 is equals to VT times IN, or you would say lane, okay? ID1 over IS, okay? So now what happens here is that if we are to substitute what we have here into equation 1, okay? We are going to have our V out to be equals to VT times lane into bracket VIN divided by IS times R in. That will be the expression of the output voltage, okay? Just take note of this. Now I'm going to define the various parameters. This is what we call ideality factor or ideality factor. VT is thermal voltage. V in is equals to input voltage. IS is equals to reverse saturation current. And then R in, of course, is input resistance. Okay? So that, that is the I. Just take note of that. At your leisure time, when you read about logarithmic amplifiers, you would appreciate this better. But just for the purposes of solution, this is all you need, okay?
Okay.
Now, the next question is that what is the importance of the PN junction diode in the feedback path in place of a resistor? You realize that the other calculation we did at the feedback, we had a resistor RF there. But in this case, we have a diode, a PN junction diode. What it basically does there is that it is there to make the circuit behave like a nonlinear signal compressor. Okay? Already, it was stated in there that the figure shows a basic signal compression circuit. So the importance of the diode there is to make the circuit behave like a nonlinear compressor of signals, where all signals fed to it are compressed. But even though the signals that are fed to it are compressed, their compression is dependent on the magnitude of the signal, okay? So if the signals are very large signals, their compression is small, okay? So the importance of the PN junction diode. So PN junction diode here helps the circuit to behave like a nonlinear compressor of signal. This is the basic reason for the PN junction diode there. Okay? If you are asked a question like this, you can just write it in simple terms like this. If you want to explain further, that is also fine. You would not be penalized for explaining further, but you should ensure that you are able to carry the information about why the PN junction diode is there, okay? And then I. Explain what will be observed out the output if the diode is open and if the diode is short. Okay. Now, the diode were open, the resistance in the circuit is infinite. So the gain would be infinity. It will be negative infinity. So note that. I hope you are there.
Yes, sir.
So if
The network is misbehaving.
yeah, so if the diode is open, if diode is open, what happens is that resistance is infinite, and hence because resistance is infinite, gain is negative infinity. Okay, and then the beta part.
The word is
I
in or
come again.
I mean the point two. I
You
want the word clear. Is it gene or what?
It's G, gain.
Gain.
Gain is negative infinity.
Is G G
G. Gain. Gain. G G GAIN. Yeah.
gain
Now, for the
infinity?
other part, if diode is short circuited, okay, what
Okay.
it means is that resistance is zero. And then two, gain is also zero. Okay. Are we all here?
Yes, sir.
Okay. Now let me quickly move on to IV. IV is more practical. It says using appropriate test and diagnostic tools. How will you test and confirm any of the circuit faults mentioned in I. Now, basically, what will happen is that you would be using a multimeter for the test of the problems above. Okay. Now, if you use the multimeter to check the problems mentioned above, the only way you can know that the circuit is short circuited or it is open is that normally when there is power supply, okay, or when there is a diode, when there is a diode in a power supply and it becomes short circuited, what happens is that large currents flow through the circuit, and this would obviously damage the diode, okay? Or in some cases, fuses will be blown. So what happens is that short circuit diodes that are not damaged, in this case, have very low resistance in both forward and reverse directions. So in essence, what we are saying is that once you have a multimeter to confirm any of these, if it is a if it is short circuit, the likelihood that the diode would burn is very high. But if it is open circuit, it means that resistance in the circuit is infinity, is very high, okay, in both forward and reverse directions. So you are not likely to have the diode getting bent. Do you understand?
Yes.
Okay. So that is basically the solution for IV. Now, when you take the B part has a question on common mode rejection ratio. It asks again, what is common mode rejection ratio? Sorry, it asks what is common mode input. Now, common mode input simply refers to a condition where two signal voltages of the same characteristics are applied to the two input terminals of the operational amplifier. Okay? So for B
BI.
is B, no, B, common mode input.
Input.
Yes. It refers to a condition where two signals of the same characteristics are applied to the two inputs of the operational amplifier. Okay. So
Okay.
that is the definition for what? Common mode input. Now, when you go on, it asks the question, define the term common mode rejection ratio, which we have already done. Okay.
Yes.
So it is more like a repetition. And then again, it gives you another question, which is the II, the BII. An operational amplifier has an open loop differential gain of 120,000 and a common mode gain of 0.5. Determine the common mode rejection ratio and express it in decibels. So it is basically similar to what we did in example 3 or tutorial 3. Okay? Are we all clear?
Yes.
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 Okay. So,
Third,
yes.
I did not get this. The common mode input.
Common mode.
That
Mhm.
the X. What is? I did not hear that word.
It is
What is
characteristics.
that? Okay. Thank you very much.
It is just the short form of characteristics.
Okay, sir. Thank you.
All right. So that is the end to our tutorials, okay?